Oh, I'm out of coffee. And I'm out of water because the girl in my grade 11 class dumped it all over the place. I don't know, man. It was right there. She just came up and... Poof. Right, Eshminder? Yeah. It wasn't Eshminder. You all right there, Simran? You seem a little under the weather. I see. You know, you go to Abbey Senior, right? You can be sick. Well, I mean, kids skip every day all blocks. Nobody ever gets in trouble. She's legitimately sick, yet she's here. Well, I'm just wondering why.
She's a good student.
I guess. Okay. So, we were doing this stuff yesterday with our algebra tiles, yeah? Everybody was in a group. They were building it up. So, I don't want to go through all that again, but I need to take my 6 x's, right? And my 3 little single squares. 1, 2, 3, 4, 5, 6, and 1, 2, 3. And I got to make them into the rectangle. How do I do it? I know it's easy.
The 3 squares, little squares.
Yep.
And then 3 rectangles, and then another 3 rectangles.
Right. So you got to go that, 3 bars, then 3 rectangles stacked on top of it, and then the 3 little guys. Oh, he means vertically. Ah, okay. So you mean this.
No.
With 1, 2, 3.
It's still not very good. That's the exact same thing you just did.
No, it isn't.
Sorry.
Totally not.
Okay.
That is a rectangle.
The 3 boxes are on the very top.
Oh, so you wanted to do this.
Okay, stop. Yeah, there we go.
Except, of course, Braden, they're the exact same thing, right?
Yeah.
Okay. Yeah.
To do it that way.
Just making sure. They both make an appropriate rectangle, yes? Down this side, 1, 2, 3. 1, 2, 3. Out this side, x, x, and 1. So it is 2x plus 1 times 3. And up here it would be the same thing, right? Ease, peas, lemon squeezy. How are you going to do this one? You all played around with the algebra tiles yesterday, so you should be able to draw this without the algebra tiles. Oh, sorry.
Oh, I know. Alright, so you get the 4x cubed. You put them in like a square pattern.
4x squareds.
Yeah, that's what I mean.
Uh-huh.
And then take 3 of the x's and put it on the right side of that. On just one of and the other 3x. Yeah.
Did he make a rectangle? Yes, he did. And he had x.
It's a gangster moment.
He had x. And then he had 1, 1, 1. And down here, he had x and x. So what are the factors? What's on this side? Don't say x squared. I have 1x and another x. So what is that? Chidu. 2x's. Abso-smurfly correct. That's one factor. What's the other factor? I got 1x and another x. 2x, and then I got 1 and another 1 and another 1. That makes 3. No flies on you, Braden. All right, and now the actual difficult one. When I gave you one like this, which I gave you x squared minus x minus 6 or something like that, you all found out that it was really hard to do if you tried to do them in order, right? This one's easy to draw because there's only 1x squared. And then this one was easy to draw because it had to be either 7 out sideways or 7 down this way, right? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And then it was easy to fill in because you knew that you had, 1, 2, 3, 4, 5, 6, 7. Oh, okay. 1, 2, 3, 4, 5, 6, 7. 8. And you needed 8. And if you went the other way, you had 1, oops, that's supposed to change color. 1, 2, 3, 4, 5, 6, 7, and then 8. Either way, you made a rectangle. I'm going to go with this one because it takes up less room. So, of course, you checked. And what do you have there? What's that? No, just the side, Maggie. We only care about the side. X, because the side is the factors. And 1, 2, 3, 4, 5, 6, 7, right? But I had to remember I needed -8 of the bars, yes? So these bars all had to be colored in, didn't they? So what does that make this? 1 or -1? -1, right? So that is x minus 7. And then down this side, what did I have there? X. And what about this? That had to be -1 as well. X minus 1. Because when the negative hits the negative, we get our positive. Is everybody good? This is the hardest one. We are going to do a bunch of work with polynomials before we get to these ones. Okay, so if you're a little dodgy on this one, that's okay. We're going to do a bunch of other stuff before we come back to this. Everybody good? All right. If you would be so kind as to turn the page over to 61, which should say factoring polynomials. Excellent. All righty then. So, we have already seen this term, greatest common factor, yes?
Yes.
We have used it this year.
Yes.
What is it? GCF. So what is it? Okay, so find me the greatest common factor. You probably can do it in your head of 18 and 27. What is it, Addison? Nope. 7 goes into neither of those. 9 goes into both of them, yes. So through guessing every single number up to 18, eventually you will get the greatest common factor. Of course, the actual way to do it, if you don't see it right away, is to do the factor trees, right? That is 2 times 3 squared. That is 3 cubed. What's the only thing common to both? 3, and there's 2 of them. So 3 squared, so that makes 9, right? Okay, now, what is the common factor between x and xy? X, because there's an x there and there's an x there, and this is x times y, right? So that common factor is x. Everybody good? Now logically, using your brains, because you're smart kids, what is the common factor of x cubed y squared and x cubed y cubed? X cubed y squared, because there's 2 y's to give there and 3 y's to give there. Is everybody good? Yeah? Everybody's good? All right, now put this whole bit together and tell me the greatest common factor of 18x cubed y squared and 27x cubed y cubed. Hold it. Amelia, not Amelia. You're not the Danish girl with the big hair like Amelia Bedelia. You're Amelia. What? 9x cubed y squared. Can everybody follow this thinking across the paper? You must stop me if you can't. Can everybody see it? Yeah? Okay. Now, please notice that this and this are both monomials, right? Everyone agrees? All right. Notice here, it's made into a binomial, yes? Okay. So, here's what we do with this. If that wasn't there, what's the GCF of 5x and 5? 5, right? The GCF here equals 5. Everybody cool? You can all do that, right? Okay, so I want you to now tell me the GCF of all 4 of these. You don't know what you're going to do with it yet. You're just going to tell me what it is. Oops, I'm using the white. That will be hard to see. GCF equals, and GCF equals. Everybody should be able to do those 4 because everybody told me they were able to follow across the top here. Would anyone like to volunteer the GCF here? Addison. 3, absolutely correct. Would anyone like to give me the GCF here? Anmal. 3, oh, you guys are on fire. Would anybody like to give me the GCF here? This is the hard one. Pardee. 2x. Does everybody understand how those 4 numbers were gotten to? Yes. Okay. So that means, Emma, you must have gotten lost somewhere up here. And I asked about that 4 times. So where up here is confusing? Can you find the GCF of 2 numbers? Okay. Do you understand why x is the GCF here? Because there's an x there, but there's no y there, so it can only be x. Do you understand why this one is x cubed y squared? Because that guy is x cubed, that guy is x cubed, so x cubed. That guy has 2 y's, that guy has 3 y's, so it can only get 2 y's. Cool there? So are you cool here? 18 and 27 was 9. And then the x's and the y's we did right here. Are you good? Okay. So I said to pretend like all of these were single things, right? So 3, 12, and 6. 3 goes into 3, goes into 12, and it goes into 6. Cool? And down at the bottom here, 2 goes into 4, 2 goes into 6, and 1x comes out. You good? All right, so everyone's good now, yeah? All right, that is the first step to the first kind of factoring. Now, I'm not going to lie to you because I never lie to you people. This, in the real world, is bordering on beyond useless. Okay? I'm 44. I can count on my hands the times I've ever had to factor variables in my life when it made a difference. I'm getting to that. When you do stuff in your life, you sometimes do math. And sometimes that math can get complicated, like building a house or painting a room or things like that. If you can do factoring, it makes that math easier later. But in reality, most of the reason we do factoring, the only reason we do factoring, is to make more complicated math easier. That's what it's for. Now, the argument that I always get that makes me want to tear my hair out is, if I'm not going to use it in real life, I'm not going to learn it. And, of course, that is idiotic, because all of you spend plenty of time working up your Fortnite kill streaks, and you're never going to be going out killing people in real life. All of you go to the gym. Never, or at some point in your life, you will go to the gym. Never in your real life will you ever need to be able to get on a bike that goes nowhere. Never in your life are you ever going to get on a machine that makes your body do the work of stairs, but you stay at the same level. Never in your life are you going to lie down, grab a bar with heavy things on it, lift it up 10 times, put it down, lift it up 10 more times, put it down, and lift it up 10 more times. You're never going to do that. I am 44. I have helped many of my friends move. I've lifted many heavy things. Never once has somebody said, hey, let me take these heavy boxes, put them on a bar so you can lie on your back and lift them that way. All right? So all that horse crap that you guys have been filled into your lives with, that if it's not in real life, you're never going to use it, don't bother learning it. Please remove that from your brain now, because all of you do things all the time that you are not going to do in real life. All right? So I don't want to hear that question again for the rest of the year, okay? Okay. Yes, Pardeep? Like twice. But I'm glad I was able to do it. All right? More importantly, this builds neural pathways in your brain and builds your brain up the way you can build your muscles up. I would submit that one of those is important and one of them isn't. Guess which is the important one? The brain one. Because when you're 80, you're not bench pressing nothing. But if you get your brain strong now, your brain can stay strong. But unfortunately, we spend all our time arguing about whether or not we should learn something. Everyone is good, yes? Excellent. Let us carry on then, cabbages. This is step 1. All right? So, if you have a polynomial, the first thing you should do is decide on the GCF of all the terms. Now, when I say all the terms, I mean the numbers, and that's a symbol for numbers, not hashtag, and the variables. So that is step 1. We have done that, yes? Everyone agrees, right? Okay. Step 2. Once we have decided on the GCF, we divide all the terms by the GCF. So this first one, right here, I'm going to call it number 1, and I'm going to do all this in green because it's the second step. We had 5x plus 5. Now we want to divide it all by 5. Everybody cool? Now do that for all 3 of these. Because the teacher came around the corner. Everyone is good, yes? You simply take the number from the first step and divide everything by that. Everybody good? All right. Step 3, which we will do in light green. No, we'll do it in red. Write our answer as follows. You take the GCF, you write it down, you put a bracket. Now, what do we call the answer when we do division? Does anybody remember that fancy word? The addition answer is a sum. The multiplication answer is a product. The subtraction answer is a difference. Does anybody remember the answer of a division question? Quotient, indeed. So what we do is we write the GCF And then we write quotient 1. And then if there are more quotients, we write all of those answers. When do we stop? When we run out of quotients. Everybody cool? And we're going to do this in red. So we've decided on our GCF as 5. We've divided everything by 5. Now we're going to write our answer like this. What was our GCF in number 1? 5, so we write 5, then a bracket. What is this quotient? What is 5x divided by 5? X, because the 5's cancel. Plus, what is our second quotient? No. 1. 5 divided by 5 is 1. And now it is done. Is everybody good? Now you do that 3 more times. What is our GCF in number 2? G-do. Right. You skipped a step, but that's fine. We write the 3 first, and then we write the answers. 2x plus 1. Then here, what's going first? What's going first? No. 3, and then our answers. What's the first one? X squared. Then what? Plus 4x. Then what? Minus 2. Everybody good? And the last one. What's going first? 2x. And then what? 2x, not 2x squared, because x squared divided by x is x, right? I got to put the answer to this. Plus what? 3. Now, one of the things that this unit is very difficult as a math teacher for is a great many of you aren't very confident. Math scares you. I don't know why math scares you. Well, I do know why math scares you, but I don't want to say it out loud. No. When you get to this unit, a great many of you will spend a lot of time saying, Mr. Myers, did I do this question right? And I will say, I don't know, kid. Did you? Because here is what you do. We've already done this, haven't we? What is 5 times x? 5x, right there. What is 5 times 1? 5, right there. Do you ever need to ask me if you've done it right? Why? Because you can check it. What is 3 times 2x? 6x. What is 3 times 1? 3. 3 times x squared, 3x squared. 3 times 4, 12x. 3 times negative 2, negative 6. Is everybody good? Now, in this white space here, you should have a little bit left. Please notice what I'm going to write and understand what it means when I write something like this. What does it mean that I wrote it that way? Pretty darned important. Always do this factoring any time you can. If it's the very beginning of a question, you see there's a GCF, do it. If you're halfway through a question, you see there's a GCF, do it. Does everybody follow me? When do we do GCF factoring? Every chance you have. Is everybody with me? Okay, so let's do the first one together, then I'm going to shut up. What was step 1? Choose the GCF. What is our GCF here? There's a 5 because 5 goes into 25, 5, and 30. What else? There's an x because there's one x there. But I can see there's two of them there. Why is it only one x? Because there's two x's there and two x's there. Because 25 only has one x he can give away, right? All right. Why is there no y here? Because 15 doesn't have a y. Everybody with me? So we've chosen our GCF. That's what we did in blue. Now, according to my color coding up at the top, which you don't have to follow, but it's kind of helpful, it's green. What do I do with that GCF now? I divide everything by that. Now, please notice it requires me to remember my exponent laws, doesn't it? And the last step, which we did in red, put our GCF first. What was it? 5x, and then we start with our answers. What's this one? 5y. 25 divided by 5 is 5. X's cancel. Y had nothing underneath it, so it stays there. Plus, what's this one? 3x minus 6xy squared. And we're done. You do B and then stop because C is weird, and I'm going to tell you why. First, you do B by yourself. Decide on the GCF and rewrite it. What is it? 2. And then we go from there. Yeah? Everyone is good, right? Okay. Now, I've already warned you C is weird, right? What is the GCF in C? And I want you to put a little star by it because there's something that weird is going to happen there. What is the GCF? 5CD. Everyone can see why it's 5CD, right? I need you to stop me if you can't see that. Does everybody see why it is 5 and 1C and 1D? Okay. Now here's where this is the weird one. What do you see there and there and there? They're all negative. We don't like negatives. All right? So, in this case, all right, we don't want the GCF. We actually want a negative 5CD because all of them also share a negative 1. Does everyone understand? If they're all negative, we're going to take out a negative. Even though negative 5 is not the greatest common factor, is it? Because negative numbers are by definition less than positive numbers. Is everybody cool with that? Jade? Okay. So we've decided on our GCF. Now we'll do our division. Negative 5, negative 5, negative 5, and CD, CD, CD. Now we write our GCF out front. Negative 5 CD. Now this is where it's going to get tricky. What is a negative divided by a negative? Positive. So what is this answer? 4C cubed, and the D cancels, right? What is this answer? Positive 6C squared D. And what is this answer? Positive 5. Any letters? No, because the CDs cancel. All right? Now, listen carefully. Everybody listening? I'm going to show you something that I don't care about, but you may have another math teacher in the future, and they might be a little, it has to be this way. If it's not this way, it's wrong. Okay, I want to show you something. If I take this exact same question, and I make this positive, are we going to take out a negative this time? So we take out a positive, right? So I'm going to change color. Don't write this down. I just want you to see it. So I'm going to use a different shade of red. 5CD has come out now. So now these are all positive, right? So what's negative 20 divided by positive 5? That's going to be negative 4c cubed, right? And this one is going to be negative 6c squared d, right? And this one's going to be positive 5. Is everybody cool with that? Everyone sees what I did? I didn't make you write it down. I just want you to see it. Everybody good? If you did this, I would mark it right. Okay? Some of your future teachers may say that's not okay. And they would still want you to bring out the negative. In which case, this would become negative. What would become of that? Positive. What would become of that? Positive. What would become of that? Negative. Does everybody see that? That is the kind of marking that makes you guys hate math. Because you've done so much work, and then you've all had teachers that would mark that totally wrong. Because they said, we want the negative out of there. What is my goal with this lesson? Is it to pick you apart, or is it to begin you down the path to factoring? It's to begin you down the path to factoring. So if you factor, that makes me happy. Everybody cool? All right. Now what about this one? Is there a GCF? So do we try to force a GCF there? No. Sometimes you can't factor. And you have to know, if you can't factor, does not factor. You don't factor. Don't force math just because you know a bunch of steps. Everybody understand? That's why I keep going out of my way to say, learn what is actually happening, not just the steps. Everybody cool? All right. I'm going to shut up. You've got a good long time right now to do page 62. It says it's an assignment. It's not, because it's your first practice at it by yourself. I want you to do page 62. Now listen. When you get to number 3, it looks weird, right? But it's not, because it's just like if it was all numbers, right? If I add 3x plus 3y, 3 is the common factor, right? So I can take it out. Okay? Try this page by yourself. It shouldn't take very long. I'd like to show you the right answers inside of 20 minutes. It's only 7. It's only like 9 questions. I lie. I'm the worst kind of liar. 6, 7, 8. No, it's exactly 9 questions.
How do you draw the pictures with the algebra tab?
Yeah, that's what we did at the very beginning of today. That's this stuff. Okay? And I know I promised you I would not make you actually do it for marks until your test, because at some point you got to prove you can do it by yourself. And this is one of those times I'm just going to ask you to do it. It's not for marks. If you still can't draw it, that's cool. As long as you can show me at least once by the end of this unit that you can draw one of them, I get to say, yep, that kid can do it. All right? Can you work together? Can you move around? Can you read in your notes? Can you ask me? So is there any reason not to have this done in 20, 25 minutes? Course not. Go.